In this iSEE Science Kit, you will find how metals and liquids you easily see in your daily life can be converted into a battery. As you unbox the iSEE Science Kit number 2, you will find 7 materials. When you open the box, you will find a lab coat, goggles, gloves, wires, LED bulbs, nails, and containers. These materials will be used for 2 separate experiments. For this second experiment, we will make a battery using various liquids. Materials for this experiment are 4 short-length red wires with alligator clips, 2 long-length red and black wires with alligator clips, 4 clear cylinder with copper and zinc metal strips, 1 dropper, 4 sample containers, and 2 LED light bulbs. You will need some materials from your home. Please prepare 2 face masks, 4 paper cups, water, baking soda solution, lemon juice, and rice, or sand. Water will be used for control, and we will experiment with lemon juice and baking soda solution. For the lemon juice, squeeze 1 whole lemon and add water to make about 12 ounces of volume. For the baking soda solution, add 3 spoons of baking soda powder to a half cup of water and mix them together. This table shows materials iSEE Science Lab Kit box and materials you must prepare from home. Please review this table and see if you have all of them. You need to change the table wrong items listed from home. Before we start, let's check your safety. Please, ensure you wear all the safety gears we provided. Wear goggles, a lab coat, and gloves. Okay. Now we are ready to go. Let's learn how to make a battery using metal strips and liquids. In this experiment, we will use various liquids to make a battery. The first part is to make an important part of the liquid battery by wrapping the copper strip with fabric. We will use common surgical masks to make some fabric and use them to wrap the copper strip. Okay. Let's carefully cut the mask on all 4 sides with scissors. After cutting, separate the mask layers and save the blue layer. This one blue layer is cut in half, and this half-size blue layer will be used to cover the copper strip so that the copper metal does not touch the zinc metal strip. Next, pour rice or sand into the paper cup a little more than half full. Take out both copper and zinc metal strips from the clear plastic container and set them aside. Then, place the empty battery container firmly into the paper cup. The rice or sand will hold the container so it does not tip over during the experiment. Once the empty container is secured, add lemon juice into the container using the dropper so that it is about near full of juice. You can slowly pour the juice into the container if you want this step to go faster. Next, clip the long-length red wire to the copper strip. Now, take the copper metal strip and wrap it around with the blue layer of the mask. Take the zinc metal strip and clip it with a long black wire. This is the similar step you did in the first experiment with tomatoes, fruits and vegetables. Here we are using metal strips instead of nails. Can the metal strips produce more electricity? You can think about this concept later. Next, combine the zinc and copper strips as a set and dip the metal strips into the lemon juice. You must not let the copper strip touch the zinc strip. For the same reason, you must not let the alligator clips from red and black wires touch each other. All of them must stay separated at all times. This is a very important step. The strips must stay close together, but at the same time, they must not touch each other. You can think about why this is important for the experiment. Now, let's connect these containers. Connect the container battery to the 2-volt blue LED bulb to see how much electricity this lemon juice and metal strips can generate. The red wire goes with the longer leg, and the black wire connects to the shorter leg of the LED. Oh, well. One liquid battery is not producing enough electricity to light up the LED bulb. Like the fruits and vegetable experiment, we will connect a second lemon juice battery. The copper metal strip from the first container is connected to the new zinc strip using a red wire. The new second copper strip must be wrapped around with a blue layer mask and not touch the zinc strip, just like the first set. As the instruction video shows, wrap around the copper strip nicely and cover the whole strip so it does not touch the zinc strip. So what happens if the copper strip touches the zinc strip? This is an interesting scientific question. After the experiment, you will need to think about this concept in your own time. This is a very important concept when you learn electricity. Again, put the copper and zinc strips together, make sure that they are not touching each other, and dip them into the lemon juice. Here it goes, nicely into the container. Okay, the second copper and zinc set is now immersed into the second lemon juice in the container. Now, let's hook up to the LED bulb and test it out. Well, no light, and they still need more power. Bring a third lemon juice container and repeat the same process. By now, you must be an expert to put an alligator clip on metal strips, wrap the copper strip with the blue fabric, and then put the pair of copper and zinc strips into the container. Oh, yeah. We can't wait to see if 3 liquid battery containers can light up the LED bulb. Here it goes. Oh, no. The third lemon juice battery container was not enough. We must make the 4th lemon juice battery and repeat the wiring process. So, let's repeat the steps and connect all 4 containers. Oh, please, LED bulb, please come alive and light up. Wow, this time, the 2-volt LED bulb is lit up brightly. So, the 2-volt LED light bulb needs 4 lemon juice batteries to brightly lit up. What would happen if we changed the LED bulb from 2 volts to 3 volts? Let us try the 3-volt LED bulb. This time, even 3 volts LED bulb is lighting up. You can clearly tell if you turn off the room light. Wow! The 4 lemon juice batteries produce enough electricity to light up 3 volts LED bulb. I see, and I see clearly, how copper and zinc metal strips are making electricity. Let's wash the containers used during this experiment, clean metal strips, and set up another experiment. This time, let's try with water. If you are confident, you don't need to use the dropper. Just pour the liquid. Carefully use the paper cup with water, make a bit of spout, and slowly pour the water into each container. Please use regular tap water from the house sink. Please remember to fill enough water in the container to submerge the metal strips. Also, you must use the new blue fabric for each experiment. It is a new experiment, so everything must be nicely cleaned. Let us connect all 4 water batteries at once. Wow, now the 2-volt bulbs are lighting up. You can clearly see in the dark. 3 water batteries can light up the 2 volts LED bulb. Why don't you try it? Let's change the LED bulb from 2 volts to 3 volts and hook it up to 4 water batteries. We see both 2-volt and 3-volt bulbs light up. Wow, we didn't know that water could produce electricity. Do you wonder what substances in the water can help generate electricity? You are a scientist now. Please think about this concept. Let's clean all containers used for the water battery and dry the metal strips before testing another liquid. How about a baking soda solution? Baking soda? Isn't this stuff that you add when you make cookies? Or clean stuff? Would baking soda make more or less electricity than lemon or tap water? Let's test it out. Yes, the same procedures, step by step, and make 4 baking soda batteries. After wiring the batteries with baking soda solution, both LED light bulbs lit up. But wait, something is different. Surprisingly, the bulbs are shining brighter than with the previous liquids. Wow, what is making them brighter? Would 4 batteries with baking soda solution light up 3 volts LED bulb? Well, let's test this hypothesis. Let's change the bulb and power up a 3-volt LED bulb. Again, the black wire goes with the shorter leg, and the red wire connects to the longer leg. We see both 2-volt and 3-volt bulbs light up. If we connect the LED light bulbs to real batteries, one battery is 1.5 volts, so we need 2 batteries to set up a total 3 volts battery. Let's connect them together. The positive side of one battery must touch the negative side of another battery. Let's tape them up and then connect them to the LED bulbs. This real battery setup is an excellent control experiment. Wow, both bulbs are lighting up really, and so bright. The bulbs are much brighter than the batteries made with fruits, vegetables, and liquids. I see the difference. Wonder what makes the difference in the brightness? I am so curious now. Let us write down how bright the LED bulb was. How about indicating the brightness by using the plus sign? One plus sign indicates the light was dim, and a triple plus indicates the light was really bright.